right, students, welcome to section 8.2. So we're going to begin to continue our discussion of probability, and we're going to look at union, intersection, complement of events is the concept here. All right, so we're going to look at union and intersection related to probability first. So consider the equally likely events for rolling a six-sided fair dice. Well, the sample space would just be the outcomes, which is you could get a 1, a 2, a 3, a 4, a 5, or a 6. So those are the outcomes of rolling one dice. Now, the question on this is, what is the probability of rolling a number that is even and prime? So what I'm going to do is I'm going to define two sets. I'm going to let E be the even, and we're going to list out all the possibilities there. So the possibilities of even numbers, of course, would be 2, 4, 6. Okay, and then we also want to I'll use P for prime. And the prime numbers out of this group would be, remember, prime numbers start with 2. They're numbers only divisible by 1 in themselves. So that would be 2, 3, and 5. Okay, so what we're doing on this is, the key thing on this is an AND probability, and AND means intersection. So whenever you see that, think of this as the probability of getting an even and at the same time a prime, like that. Okay, so what we're going to do is we do this. We got to look at the intersection of these two events. All right, so we're going to write down the probability of getting an even intersect a prime number. Of course, there's 6 possibilities that can happen. Now, what is the intersection between these two sets? Okay, the only thing that's in common is a 2, so we would end up getting the intersection would just be the set containing a 2, and there's only one possibility. So that means the answer of this problem is that would be a 1/6 probability. Okay, so if it's and, you start thinking about intersection. All right, next problem says, what is the probability of rolling a number that is even or prime? When you think of this, you want to think of union when you see the word or. So this is the probability of even, union, prime, like that. Okay, so I'm going to do the same thing on this. I'm just going to write down these two sets again. So the even numbers are 2, 4, and 6. The prime numbers would be a 2, 3, or 5. Okay, so what we do is when we do the union of these two sets, remember that just means join the two sets together, but don't repeat anything. Okay, so I'm going to write this as E union P. And again, don't repeat anything. So we have a 2, we have a 3, we have a 4, we have a 5, and we have a 6. Okay, don't repeat the 2s. Okay, so that would be what's in the union of those two sets. So then we would say the probability of getting an even or, that would be, there's 5 possibilities here out of 6 total possibilities there. Okay, so that would be a 5/6 probability as the answer to that problem then. All right, so it's a little bit different on that. So remember, if you see and, probability of this and that happen, and think intersection, if it's the probability of this or that, then you want to think about a union. Okay, all right, so the next problem, this is a different scenario. This says, what is the probability of rolling a number that is odd and divisible by 5? So we're going to list out the possibilities on this. So let's list out, for odd, let's use O for odd, and let's list all of the odd numbers that can come up on a 6-sided dice. So you could either get a 1, a 3, or a 5 would be that. Okay, divisible by 5, if you look at the sample space, the only number divisible by 5 is the 5. So I'm going to write divisible by 5. Pick a letter, let's just say D for divisible, and then that would be the set containing 5, like that. Okay, so what we're doing on this is we're doing the probability of getting an odd, and since it's and, we're talking about intersection. Okay, so we're going to do the intersection of these two events happening. Okay. All right, so what is the intersection of these two sets? What do you see in common? Okay, there's a 5 in common. Okay, so what we'll have on this is there's only one thing in the intersection. So again, it's a 1 out of 6 probability would be the probability of a number being odd and at the same time divisible by 5. There's a 1 out of 6 chance of that happening. Okay, all right. So the next one, let's see what this one says. This is the probability of odd or divisible by 5. So what you think about here is a set union. All right, so if you look at these two sets, the union of odd and divisible by 5, remember you're joining the sets together but not repeating. So what would that be? You'd have a 1, you'd have a 3, you have a 5, but don't repeat the 5. So you're joining those two things together, but not repeating the 5. One way to always do a union is just write down the two sets and then just cross out anything that you repeated twice, okay? So that means that the probability of getting an odd union divisible by 5, well, there's 3 ways this can happen. So it's 3 out of 6. That fraction would reduce to 1/2. So that is a 1/2 probability. All right. Next thing is down here, these next two problems, last two on this page. This says, what is the probability of rolling a number that's even and odd? Okay, so remember, what does and mean? Right, intersection. So you're talking about an intersection there then, okay? So let's list out these sets. So the odd numbers would be 1, 3, or 5. The even numbers on a 6-sided dice would either be a 2, a 4, or a 6. Okay, the intersection of odd intersect even is going to be the empty set. So there's nothing in common between those two sets. So it's impossible to roll a die and an even and odd number comes out at the same time. Okay, if that happened, there'd be something wrong with the die or there'd be something wrong with your eyes. Okay, so the idea is we'd say probability of odd intersect even would be 0. Okay, so that means, again, that this is impossible. Okay, that can't happen. All right, and the last problem on this page says, what's the probability of rolling a number that is odd or even? So this means union because of the word or. So then if you did odd union even, okay, well, that would just be all of the numbers. You just go 1, 2, 3, 4, 5, 6. So just joining those two sets together, not repeating anything. So there would be 6 outcomes there. So that would mean that the probability of getting an odd union even, what would that be? There's 6 outcomes in this union out of 6 possibilities, so that's 1. So this would be an example of an event that is absolutely certain to happen. So anytime you roll a dice, you're guaranteed that you're either going to get an odd or even number. If you don't, the dice are screwed up or you're screwed up, all right? So that's the way I'd look at that then. Okay, so that would kind of get us started on that. Now what I want you to do is go to the next page, and I'm going to give you a little time to sort these problems out. So I'm going to have you pause and work these particular problems out then. Just 4 problems. I've already listed the sample space, so I want you to try to get these probabilities crunched out. I always recommend write down what your sets are, determine if it's a union or intersection, then you can complete your probability. Okay, moment of truth. Let's check your answers and see if you got these right. So these are the answers. The first, number 2, I got 7/12. Number 3, I got 1/4. Number 4, I got 1/2. Okay, now I will go through these, and if you got these okay, you can just, skip ahead a little bit in the video if you want to, or you can watch. So what I did on this is odd or multiple of 5. Since it's or, that's what makes it a union. Okay, so I just listed these out. So all of the odd numbers, I have O as 1, 3, 5, 7, 9, 11. M, the multiples of 5 in this list are 5 and 10. The union of these two sets would be 1, 3, 5, 7, 9, 10, 11. Again, don't repeat anything. So there is 7 outcomes in this union. There's 12 in the sample space. Therefore, it's a 7 out of 12 probability. Okay? You can do these problems in your head if you're pretty careful, but it's best to just identify the sets and carefully write everything out. Okay, the next problem was the probability of even and greater than 6. So since it's an and problem, then it's an intersection. So the even numbers in the sample space are 2, 4, 6, 8, 10, and 12. The numbers greater than 6 are 7, 8, 9, 10, 11, and 12. The intersection of these two sets is 8, 10, and 12. Therefore, there's 3 outcomes. So the probability of getting an even intersect number greater than 6 is 3 out of 12. That reduces to 1/4. So there's a 25% chance that you're going to pick a ball that's even and at the same time greater than 6. Okay. All right. Next one, probability less than 5 or greater than 10. Okay. Less than 5 would be 1, 2, 3, 4. Greater than 10 would be 11 and 12. Again, it's an OR problem, so you should figure out that it's a union. The union of these two sets, join them together, 1, 2, 3, 4, 11, 12, no repetition. 6 outcomes, so you have a 6 out of 12 probability. Divide by 6, you get 1/2. All right, that's how it goes. What do you think? Okay, all right. Most probability is all about counting when you get right down to it. Okay, that's the skill that's required. Organize the sets, understand whether it's union or intersection, and be able to count the sample space and the event out correctly. Okay, so down at the bottom of the page, this is just kind of what we talked about. If you're doing a union, remember a union is just everything that's in A or B. So a set union would be this part right here. That's just joining the two sets. So that would be the Venn diagram for the union of A and B. Okay, if it's an intersection, then that's what's in common. So that would be all of the elements in the sample space that are in A and B at the same time. That's the key. So that's intersection. Okay, so an event A or B is a union. An event A and B is an intersection. So that's to summarize what we did. So this is kind of what you want to know. In general, the probability of event A or event B is going to be written like this. You write this as the probability of A union B, because it's OR, and then the probability of event A and B happening, what's that? Okay, that's a set intersection like that. All right, so that kind of gets us started on that idea. Okay, next thing we're going to get into a little bit is the probability of the union of two events. There's a formula for this. And what you're doing on this is it's the probability of the first event happening plus the probability of the second event happening minus the probability of both happening. So it's the intersection like that. So a couple of definitions I want to go through here a little bit is two sets are said to be mutually exclusive or disjoint. Those are two terminologies that mean basically the same thing. Disjoint sets would mean this. In this diagram, the intersection of A and B is the empty set. So that's what disjoint sets mean, is there's nothing in common. Sets are not disjoint, however, if there is something in common. Okay, so in this case, A or C intersect D has something in it. It's the set containing 7. So that does have an intersection. That does not. No intersection on disjoint. An intersection exists with at least one element on not disjoint sets. Okay? So if we go down the bottom, we're going to kind of begin to put this together from this Venn diagram. Now, what this Venn diagram is saying is you have two sets, F and H. This is saying this piece here has 11 in it, and that's just this kind of it's like a crescent part of a moon. There's 8 elements in the intersection. There's 5 in this part here, and then there's 7 outside. So I'm going to kind of shade these things like this just so that you're real clear on what that is. The 11 is that part right there. The 5 is this part here. 8 is the intersection. Okay, so I'll do that in blue. And then 7 is what's outside of all of this. Okay, so that would be the part that's basically, you know, outside. I'm not going to shade the whole thing. So those are the sets. That's actually 4 disjoint sets that we learned how to do on our Venn diagrams then. So what we're going to do is we're going to find some probabilities on this then. So first of all, we're going to fill this out to begin with, and this is important to start with. So we're going to look at the number of elements in the intersection of f and h. So how many elements are in the intersection? There are 8. Okay. How many elements are in the union? Now, see, we've learned this before. That's just 11, 8, and 5 added together. So 11 plus 8 plus 5 is 24 items. Okay, this one's the one that's always a little harder for students to do. This is the way I recommend you do this. Put a check mark by everything that's in F. Now that's in F and so is that. Okay, now put a check mark by everything that's not in H. So if you're not in H, then you would be with the 7 or you'd be with the 11. So what I checked twice is 11. Okay, so that set right there is talking about that crescent moon part. That's the part that's in yellow, okay, is what I'm doing, okay? All right, and that's kind of a good strategy for doing that is just use check marks when it's hard to do. The next one's the same way. We're going to do an intersection of H. So H would be the 5 and the 8. Those are the 2 numbers in the circle H. Okay, like that. And then what we'll do is we'll do all of the things that are not in F, which would be that and that. Where did they overlap? Where's the 2 check marks? Okay, they are at the 5. So what that means is this set is really the green part right there. Okay, that's what that is. Okay. All right, that's just kind of a nice way to learn how to keep track of that in your head. Okay, now what's the universe? The universe is everything together, so you'd have 11 plus 8 plus 5 plus 7. You work that out, that should be 31. All right, so you want to know what those sets are in that Venn diagram. So now what we're going to do is we're going to crunch out some individual probabilities here. So we're looking at the intersection of F and H. Okay, the intersection of F and H is the part that's in blue. So that would be an 8 out of 31 probability. So that's 8 31st. Okay, the union would be the 11, 8, and 5. So that would be, you'd figure this out by doing 11 plus 8 plus 5 out of 31. So there's 24 elements that are in that union then. So that's a 24 over 31 probability. Okay, the next one is F intersects H prime. That's the yellow part. So that would be 11 out of 31. Okay, so I'm going to try to color code these, I guess, and that'll kind of help you a little bit. So that's that part. And then the next part is H intersect F prime. That's the 5. So that would be a 5 out of 31 probability. Okay. The probability of the universal set would be there's 31 elements that you're considering out of 31. So that's 1. Okay. So that's how you do those probabilities. Now, this next thing I'm going to do on here is I'm going to kind of use the check mark approach too. So this is saying everything outside, since that's a complement, it's outside of the intersection. So if you're outside of that intersection 8, then you're considering those 3 numbers. So to work this out, you would do 11 plus 5 plus 7 out of 31. So that looks like 16 plus 7, 23 out of 21 would be what you get there. Okay? Not 21, 31. Okay, so that's a 31. 23 out of 31. Okay? And then the next one, I think I have a typo on this. Let's see. So that's 23 out of 31. The next one, I intended to have that. the prime there. So what we're doing with this one is it's everything outside the union. So tell me what's outside of the union. Okay, the union is 11, 8, and 5. 7 is outside, so that would be a 7 over 31 probability like that then. Okay? All right, so that's it. So pause and think about this if you need to. Otherwise, we're going to go to the next page, and I'm going to put you to work and let you try one of these and see if you've got this put together okay. Okay, so take this Venn diagram, fill this out, and fill out those probabilities. Please pause the video and check. All right, moment of truth. Let's see how we did here. And I'll talk through these and you can check your answers on this. So you can go ahead and pause for a minute if you want to and just check how you did and then resume, and then I'll be doing the explanations here. Okay, so intersect T intersect O. Okay, that's just, or I'm sorry, union. That's just the 15, the 30, and the 10 put together. So that's 55 possibilities there. Okay, now some of these things I'm going to highlight. So the intersection of those two sets is the football-looking shape that's in common between those two sets. So that's your 30. Okay, the next one goes like this. This is the intersection of O and T prime. So one approach on this is just, okay, that's what's in O. T prime is everything outside of T, which would be this and this. So basically, that is the 10. Okay, so I'm going to highlight that. Again, use the check marks or whatever strategy helps you to do that then. Okay, so I'll highlight that part in blue. Okay, like that. All right, then the next part goes like this. This is everything in T, which is this and this. And then everything outside of O, which is this and this. So that's represented by the 15, okay? All right, so I'll pick a different color and I'll highlight that. We'll say like in this green color like that. Okay, so that gives that to you. And then the universe would just be everything put together. All right, so we'd have 60 if you add those numbers up like that then. So that's just 15 plus 30 plus 10 plus 5 is how I got the 60 on that. Okay, so here's how I do the probabilities now. So the probabilities go like this. If you're doing probability of T union O, the union is the 15, 30, and 10. So I add that together to get 60. I'm sorry, add the numerator together. 15, 30, and 10 is 55 out of 60. And then what I do is I reduce the fraction by a factor of 5. You can use your calculator if you have to, but I'd like you to be able to do this without your calculator. So that's 11 out of 12. So that is an 11/12 probability. Okay, the next one would be everything. This is saying everything outside the union. Okay, so if you're outside the union, that would just be the 5. Okay, so that would be a 5/6 probability. You would divide by 5. And if you do that, you would get a 1/12 probability. Okay, the next one is the set intersection. So that's the 30. So that would be 30 out of 60. That fraction reduces to a half. And then the last one is T intersect O prime. That was the one that was the 15. So that was the one that we highlighted in green. So that would be, but that's outside of that though. So this is a little bit different. So what you're doing is everything outside of that would be 30. Hold on, did I get that right? Oh, okay, never mind. I'm doing this wrong. Okay, I'm not paying attention here. Okay, so it's basically this. It's everything outside of the intersection. The intersection is 30. All right, what's outside of that is 15, 10, and 5. So if you add 15, 10, and 5, you get 30 out of 60, so it's 1/2. Okay, so that's how you make that determination on that one then. Okay. All right, so hopefully that went okay for you. All right. Pause the video anytime you need to. All right, so if I move down the bottom here, I'm just going to go over this diagram right here and kind of explain this a little bit. The idea kind of works like this. I'm going to demonstrate this just with some numbers. I'm just going to put some numbers in here. So I'm going to say this is 10, this is 5, this is 15, and let's say there's 20 out there. So I'm going to show you how you would do the probability of the union and why this formula works the way it does. All right, so according to this formula, if we do the probability of A union B, we would do the probability of A plus the probability of B minus the probability of the intersection. Okay, and then we'll see if this works. So let's not even do the formula. Let's just think about how we just learned how to do this. Well, A union B would be 10, 5, and 15. Okay, the universe would be everything added together, so it would be 10 plus 5 plus 15 plus 20. All right, so that means that the numerator would be 20 plus 10, or 30. The denominator would be 50. So that would be a 3/5 probability. Well, let's see if the formula works, and this will help you understand why you have to subtract off that intersection. So basically, this would go like this. If you're doing the probability of A, the probability of A would not be 10 out of 50. It would be 15 out of 50. Okay, so that's the total of 10 and 5. The probability of B would be 5 plus 15, or 20 out of 50. So notice that is 35 out of 50. It's too big. And the reason is because we counted this twice. That's why we have to do the intersection. The probability of the intersection is 5 out of 50. So now if you do this, you got the 35 out of 50 minus the 5 out of 50 gives you the 30 out of 50, which would give you 3/5. So the thing is, if you don't subtract that intersection, then you're counting that twice. Okay, does that make sense? Okay, that's why you got to do that. You can't count the intersection twice, and you've counted the 5 twice. You've counted it in the probability of A and the probability of B. That's why you turned out with too big of a number. Okay, now what happens on this if the events are mutually exclusive, which they certainly can be? Mutually exclusive or disjoint sets just means that the intersection is empty. So these two sets don't have an intersection. So let me just explain how this would work. So let's say here we have the number 20, say that's 30, then outside is 50, okay, like that. Well, if we did the probability on this, if we did the probability of A union B would just be 20 plus 30. And then the universe would be, there's no intersection, so you're not going to have 4 numbers, you're going to have 3 numbers, so that would be 20 plus 30 plus 50. So you would end up getting 50 out of 100, so that would be a 1/2 probability. So according to this, the formula works like this. So what happens with this one is you have probability of A union B. The general formula that I had on the previous example was probability of A plus probability of B minus probability of the intersection. Okay, so here's what would happen. The probability of A in this problem is 20 out of 50. The probability of B in this example is 30 out of 50. What's the intersection? The intersection's nothing. So it's 0 out of 50. So see, notice you don't have to worry about that. So you get 50 out of 100, so you're going to get a 1/2 probability on that. So what this is saying is if you have disjoint sets, if you don't have an intersection, then you just do probability of A and B and add them together. Okay? You can always use this formula. It's just if the intersection's the empty set, you don't have to worry about it. Okay? So if you use the same formula, you would get a 0 there anyway. So to be safe, you could always use this formula right here, okay? Mutually exclusive is just kind of a special thing that can happen. All right, so on the next page, go back to the cards, and not cards, dice. These would be called dice, teacher. Okay, so we're going to look at some basic events on this, mostly some OR probabilities. A few are going to have AND probabilities maybe on that too then. So we're going to utilize this formula mostly on this. Okay, so what I'm going to do on this is I'm going to identify sets just kind of like this. I'm just so I can use symbols. Okay, so I'm going to say sum greater than 9. I'm going to use S for sum. Okay, so I'm going to identify that like that. Okay, that will be the set of all outcomes like that. And then the other one is the first die is a 6. So that we're going to look at the first die equals 6. So let's use F for first die. So S is sum greater than 9. F is first die is 6. Okay, and we're not going to list all these out in a set. What we're going to do is just apply this formula. So let's write down the formula. What we're doing is an OR probability. So we're doing the probability that the sum union first die is 6. So that's a union. So according to the formula, what you do is you add the probabilities. Okay, then you subtract off the intersection. Like that. Okay, so it's all a matter of counting. Let's first of all start with the probability that the sum is greater than 9. Okay, well, that would be a sum of 12. That would be a sum of 11. This would be a sum of 10. Okay, and then that would be 11. Everything else, the sum would be 9 or below. So if you count that, there's 1, 2, 3, 4, 5, 6 possibilities in that probability. And that's 6 out of 36. You don't want to reduce the fraction until the end on these problems, so that's 6 out of 36. Okay? Right? Now, what I'm going to do is go to the next thing, and we'll try to figure that out. And again, I'm going to use a highlighter because that'll help you identify where these intersections are then. So now we're looking at the first die is, let's see, it said the first die is a 6. Okay, well, that would mean these outcomes right here. Okay, so it would be this, this, and this, and this, and this, and this. Is there an intersection? Yeah, there's an intersection. See, the colors kind of blended together right there, and they're kind of making a greenish color there, right? So the probability of the first first dice being a 6, there's 6 possibilities there. So that would be a 6 out of 36 there. Okay, now the intersection would be these 3 right here, so you would subtract off that intersection. Since the intersection has something in it, we're going to say that those sets are not disjoint. Okay, if they have an intersection, they're not disjoint. And then work this out. 6 plus 6 is 12. 12 minus 3 is 9. So it's a 9/36 probability. Then you can reduce that fraction by 9 to get an answer of 1/4. So that one has a 1/4 probability then. All right. Okay, problem done. Okay, I'm going to erase this on here because I think that's real helpful to see my thought process and just use highlighters. Okay, so the next thing is the number on the first die is odd or the sum is 12. So I'm going to identify sets. So let's say F, and this set indicates first die odd. Okay, and then we'll use S for the second one. That's going to represent that you have a sum of the 2 dice is 12. Okay, again, we're doing an OR probability, so we're going to use the union formula. All right, write down your formula. So we're doing the probability of F union S. That means we do the probability of F plus the probability of S minus the probability of the intersection. Okay, like that. All right, well, let's just start identifying these things then. All right, so let's identify the first die is odd. Okay, so the first die could either be a 1, it could be a 3, or it could be a 5. Okay, that is what that's indicating. So that would be, just count that out. That would be 6 plus 6 plus 6. So that would be 18. That's a total of 18. Therefore, that probability would be 18 out of 36. Okay, like that. Okay. next thing I'm going to do is we're going to do the probability that the sum is 12. The only time that happens is right there. So what's that probability? Yeah, that's 1 out of 36. Now, did these things overlap? Do the colors overlap? Now, they don't, so that means the probability of the first die being odd and the sum being 12 at the same time is 0. Okay, since the intersection of those two sets is empty, we would say yes, those sets are disjoint. Okay, and then when you get the answer on that, you would end up getting 19 out of 36 would be the probability of that happening then. Okay, aren't these fun? I sure think so. All right, next one. I'm going to erase all my scribbling on the dice here and highlighting because I think that's helpful for you to see this. So the next one says the sum is less than 4, or, again, it's a union, sum is greater than 10. So let's identify the sets. I'm going to say L is sum less than 4. I'm not going to list that out, but you could if you wanted to. And then S is going to be the sum is greater than 10. Okay? So the probability goes like this. We're going to say the probability of L union S is equal to the probability of L plus the probability of S minus the probability of L intersect S, like this. And again, I'm just going to highlight these as we go. So the probability of the sum being less than 4. That would be a sum of 2. That would be a sum of 3. So there's 3 possibilities on that then. So that probability would be 3 out of 36. Okay? All right, so the second one would be the probability that the sum is greater than 10. What would that be? You'd get a 12 or you would get an 11. Okay, so again, that looks like that is a 3 out of 36 probability. All right, what's the intersection? Okay, the intersection is empty, so these are disjoint sets. So it's impossible for the event of the sum being less than 4 and at the same time greater than 10 is not, there's nothing in common between those two sets. So that's 0 out of 36. So you'd have 6 out of 36. Then you can reduce that fraction by 6. So what do you get? Okay, you get 1 out of 6 would be that probability like that then. Okay. All right, so that's how you do that. Okay, let's see what we got on the next one here. All right, so the next one says we have the probability of both die have odd numbers. Okay, so again, I'm going to just list kind of what's going on this then. Oh, it's doubles or, okay, I didn't read that right. So it's doubles or both die have odd numbers. Okay, so again, I'm going to write the sets. D is going to be doubles. And then I'll use O for odd, so this just means both die have odd numbers. Okay, and again, it's a union, so we're going to do the probability of getting doubles, union, both die are odd. So that would be the probability of doubles plus the probability both die are odd minus the probability of the intersection. Okay, like that. All right, let me zoom out on this just a little bit here, and then we'll look at this diagram of the dice and see if that helps us a little bit to figure out this problem. Okay, so to begin with, let's start by looking at the probability of doubles. Okay, well, the doubles would be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So what's that probability? Okay, there's 6 things there, 6 doubles, so that would be 6 out of 36. Okay, take a different color and we'll do both die are odd. Okay, there's going to be some overlap in here. So that would be an overlap there. Both die are odd. Both die are odd there. Both are odd there. You can forget about this one. That would be a good one. This would be a good one. And that would be good. Okay, nothing here because you have an even dice on the first one. Here, let's see, 5 and 1, 5 and 3, 5 and 5. So there's an intersection right there then. And then nothing here. All right, so if you look at what I highlighted, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a 9/36 probability like that. All right, so we got that. All right, what's the intersection? What blended? There were 3 things that blended. There was the intersection is doubles and both die are odd. Okay, so there's 3 possibilities there. So that would be -3 out of 36. That means that the sets are not disjoint, since the intersection has 3 elements in it. And then if you put this together, you would have this. You would have 9 plus 6 is 15. 15 minus 3 is 12. So it's a 12 out of 36 probability. Divide by 12 to reduce the fraction. Therefore, you would get a 1/3 probability on that then. Okay, so you just got to use that formula very meticulously and carefully to get those probabilities. Okay, so let's see. I'm going to put you to work on the next page and see if you can put this together. Just more problems with dice. Okay, so I'm going to go ahead and zoom on this a little bit and let you go ahead and see what you can do on these. And then come check your answer when you're ready. Okay, so go ahead and check your answers and see how you did. So I've got all the answers highlighted in green, and pause if you want to look over this a little bit. I'm going to go ahead and explain what I did on these problems. Okay, so I went ahead on the first thing here. This one said the sum is less than or equal to 6. Okay, so I'm going to highlight these and count as I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it's got to be less than or equal to 6. So there's 15 things that I highlighted. So this would be the sum can be 6 or less. So that kind of gives you that diagonal right there then. Okay. So I'm going to kind of do something like this, just sort of highlight that like that. All right. So those are the 15 possibilities there. All right. So that will give us that probability there. Okay, the next one is the probability that the, whoops, I highlighted the wrong thing. So that's the probability the sum is less than or equal to 6. Okay, then the next one is the sum is less than or equal to 4. Okay, well that would be this, this, this. Now it can be equal to 4 because it says less than or equal to 4. So you would have this, this, and this. Okay. So if you count that out, that's 1, 2, 3, 4, 5, 6, right? Oh, it says less than 4. I'm sorry, I wrote the wrong thing on there then. Crap. Okay, let me do this again. Shoot. Okay, so it goes like this. So the first one, I'm going to just re-highlight that like that. Those are the 15 possibilities for the first set. And then this one said less than 4. Okay, so less than 4 would just simply be this one, and this one. Okay, so that second set would be these 3 things right here then. All right, okay, so there's 3 in that, so there's a 3/36 probability there. Then the intersection would be these 3 here. Okay, so that would be -3 over 36. Add that up, you get 15 out of 36. Reduce the fraction, it's 5/12. They're not disjoint because there's an intersection. So if you kind of look at what I highlighted in yellow and what I highlighted in blue, see how they turn green? Okay, the colors blended, so that's your set intersection then. Okay, all right. So the next one, I'll kind of erase this because this is kind of a handy way to show this again. So the next one, when I identified the sets, I said F is the first die is odd. S is the second die is 6. So we're doing the probability of F union S is the probability of F plus probability of S minus probability of intersection. So I'm going to go ahead and we're going to highlight the probability that the first die is odd. Okay, so that could be all 6 of those. Could be all 6 of those. So the first die either has to be a 1, a 3, or a 5. So that's 18 possibilities right there. Okay, 6 plus 6 plus 6 is 18 possibilities. So that takes care of that. Okay, the second one is, the second die is a 6. Okay, so if you look at that, that would be this, or this, or this, or this, like that. Okay, and it would be all 6 of these right there. So the 6 possibilities where the second die is a 6. So that would be a 636 probability. Now, where did the colors blend and make it green? Well, right there. Okay, so what you'd have there is that's a 336 probability in the intersection. Since there is since the intersection's not empty, they're not disjoint, then 18 plus 6 minus 3 is 21. Reduce the fraction by 3, you get 7/12. Okay, so that's how that one goes. All right, and let me erase this and let's do the last one here. Okay, so I identified the sets on this like this. We said the first die is prime. So I'm going to go ahead and figure that out. Okay, and I'm going to go ahead and highlight that. So the prime numbers are 2, 3, and 5. Okay, so I'm going to highlight where the first dice is prime. Okay, first dice is a 2. First dice is a 3, or the first die is a 5. So there's 18 possibilities where the first die is a odd number. Hold on, what is wrong? No, I'm on number 3. I don't even know what I'm doing here sometimes. Okay, so the first die is prime. Okay, so that's 18 out of 36. Okay, the second dice is odd. So I'll highlight that part in blue. So second dice is odd. That could be, the second dice is a 1. The second dice is a 3. Or the second dice is a 5. Okay, like that. All right. So notice that, the colors are blending. That's kind of where your intersection is going to occur, is where the color turns green. Okay, like that. All right, so when we put this together then, on this, the probability the second dice is odd would be all of this here, this row, and that row. So there's 18 out of 36 possibilities there. The intersection would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a 936 probability like that. Do the arithmetic. 18 plus 18 minus 9 is 27. Reduce the fraction by 9. You get a 3/4 probability. Okay. So that's how I would do that. Again, you're doing your homework and stuff. It's make yourself a little worksheet out with a bunch of these dice things and then use a highlighter, and I think you'll do just fine. Okay, so that's how I would figure those out, and that's how those probabilities should have worked out for you. Okay, so if I go down the bottom of the page, I'm going to talk about a real simple idea here, and the idea is if the probability of an event happening is A, then the probability of it not happening would be 1 minus the probability of it happening. Okay, and you can do this backwards. If you can also say the probability of the event is 1 minus the probability of the event not happening, or you can do it like this. So basically, the probability of an event happening plus the probability of the event not happening is always going to be 1. Okay, so it kind of goes like this. You do these examples down at the bottom here. So let's say that a meteorologist says that the probability of rain is 0.75. Then the probability of no rain would be found by just doing 1 minus 0.75. So that would be 0.25. Like that. So this is just kind of in symbols is saying this. If the probability of rain is 0.75, then we would say the probability of not rain, which we represent that way, would be 1 minus 0.75. So that's what we're doing, is using this formula right here. Okay, the next one says the probability of winning a game is 0.3. So I'm going to write this at the side like this. Probability of a win is 0.3. So the probability of not winning would be probability of W prime. So that would be 1 minus 0.3. Therefore, that's 0.7. Okay, I want you to notice what happens is what this symbol right here means. It just means if you add the probability of rain plus the probability of no rain, you should get 1. Same thing on the next one, probability of winning, 0.3, plus probability of not winning should add up to 1. Okay, so the next one says if the probability of rolling a 1 on a 6-sided dice is 1/6, what's the probability of not rolling? Okay, well, this would go like this. We'll say probability of getting a 1, okay, that would be 1/6. So the probability of not getting a 1 would be 1 minus 1/6. So that would be 6/6 minus 1/6. So that's equal to 5/6. Okay, and again, on this problem, the probability of getting a 1 plus the probability of not getting a 1 should add up to 1. So the probability of getting a 1 is 1/6. Probability of not getting a 1 is 5/6. Notice they add up to 1. All right, so that's what that is basically saying, right? So that's what we mean by the probability of a complement of an event. Okay, move to the next page, all right? So now we're going to look at the odds and talk a little bit about how odds work in probability. So we have 2 definitions on this, so it works like this, okay? We say the probability for an event happening. Well, that would be equal to this. This is mainly what you have to know, is it's the probability of the event happening divided by the probability of the event not happening. Okay, that's the odds for. The odds against is just the reciprocal of that. So the odds against an event would be the probability of the event not happening divided by the probability of the event happening. So they're defined 2 different ways. So what we're going to do is look at probabilities and then start talking about odds, okay? So down on this example, what this says is what are the odds for rolling doubles with a pair of standard fair dice? Okay, so here's basically what we want to do. Let's define our events like this. So basically it would go like this. I'm going to say D is basically doubles. Okay, you get doubles. Okay, D prime would be you're not getting doubles. Okay, those 2 probabilities would add up to 1. So what you want to do when you do the odds for doubles, okay, you would basically do this. You would do the probability of getting doubles divided by the probability of not getting doubles. Okay, so that's what you would have to work out. So if you look at this in the die, there are 6 possibilities on the doubles. Okay, I want to pull up that diagram here just in case it's helpful. Okay, like magic, the dice appear. So just to kind of as a reminder, the doubles would be this right here. All right, so when we work this out, it would go like this. We would say the probability of getting doubles is 6 out of 36. The probability of not getting doubles would be 30 out of 36. Okay, remember these 2 probabilities will always add up to 1 when you're doing the odds formula like that then, right? So it's 6 out of 36 for doubles, 30 out of 36 for not getting doubles. Okay, that's the idea. Now, the way we work this out and translate this to odds is like this then. So what happens is this just divides out. I'll explain why that is up here. You don't have to write this down, but you want to know this. If you do 36 divided by 30 over 36, when you divide fractions, you multiply by the reciprocal. Okay, so it goes like that. That would divide out, and that would leave you 6 over 30. So what you would get with this is 6 over 30. And then you could reduce that fraction by a factor of 6. So you would get 1/5 like that. Now what you do is you write the odds like this. You either say 1 to 5 odds, or you can say 1:5. Those are the most 2 common ways to write odds. So there would be a 1 to 5 odds of rolling doubles. Okay, we'll talk about what that means just a minute here. Okay. The next one is the odds against doubles, and that would just be the reciprocal of this. So it goes like this. We would say the odds against I'm going to crunch out the formula, even though you can get the answer in your head. The odds against doubles would go like this. So it would be the probability of not getting doubles divided by the probability of getting doubles. So the probability of not getting doubles is 3 out of 36. The probability of getting doubles is 6 out of 36. Okay, that would divide out, and it would end up giving you 30 over 6. And if you divide that out or reduce that fraction by 6, you would end up getting this. You would get 5 over 1. So it's the reciprocal, like I said. So we would just say 5 to 1 odds, or we would say 5 colon 1. Those are the two common ways to write odds. Okay, like that. All right, so you're just doing individual probabilities. Okay, now what this means is, this is kind of a good way to explain this. It says, if you bet $1 on rolling doubles, what should the house pay, plus returning your $1 bet? If you roll doubles in order for the game to be fair, what should be like this? So the idea basically on this is, since the odds for doubles is, let's see, that was 1 to 5, then that means this. It basically means that on this, the payout on a $1 bet should be $5. Okay, that's because it's 1 to 5 odds. So that's how we know that. You can use odds to figure out payouts. That's the way casinos kind of work their payouts. Now this would just be kind of break even. So the game would be fair. Now, if they wanted to rig it in the casino's favor, then they would want to they would pay out less than $5. If it was in your favor, then they should pay out something that's bigger than $5. So that's the way that is. Okay, so the next thing that I wanted to look at is, this says, if the odds for an event are 4 to 1, then what's the probability of that event? Well, first of all, what you do is the probability for that event, you do it like this then. So the total would be 4 plus 1. Okay, so you have to add those two numbers together to get that total. Notice on the last problem when we had 1 to 5 odds, 1 plus 5 is 6. Well, there were 6 possibilities on that then. Okay, so that's the idea. And then this would just be, what's the probability of the event happening? So what you would want to do on that then is just work this out. So you do 4 plus 1. The odds for that event are 4. So this would be a 4/5 probability for that event happening then. Okay, so that's the idea. Okay, that's how you convert odds back to probability. And I'm going to add this on here. If I wanted to do the probability against, well, the odds against would be this. So the odds against would be equal to 5 to 1. So what we would, 4 to 1. I'm on this problem right here. So it would be 4 to 1, like this. So it would just, Brad, gosh, pay attention. Okay, so if the odds for are 4 to 1, then 1 to 4 would be the odds against. So the probability against would be 1 out of 5. Okay, so notice these two probabilities add up to 1. So that's how you can convert odds back to a probability. Okay, all right, well, what does it mean for the odds? If you have 1 to 1 odds, let's talk about what that means. Well, if you have 1 to 1 odds, if that's the odds for, then the probability for would be done like this. Again, you would add the two numbers together, and then the first number would be the probability for. So that would be a 1/2 probability. So anytime you have 1 to 1 odds, it just means you have a 50% chance of winning. Okay, so it's kind of good to see these things like this then. So like if you had, say you had 1 to 2 odds, if you had 1 to 2 odds for, then that would be a 1/3 probability, and so forth. If you had 1 to 4 odds, that would be a 1/5 probability, and so forth like that. Okay, so those kind of things are kind of helpful to know. Okay, so down here at the bottom, this is just showing you these are the different ways to write odds: 5 to 1, 5:1, 5/1. Okay, and if the odds for are A over B, then the probability, like I showed you, is A over A plus B. That's what I did on that example D, and the same idea on example E. Okay? All right, so let's crunch some of these out. So let's see. I'm going to go ahead and do example 5 and 6, and then I'll let you do a couple of problems to see how well you put this together then. Okay, so on this example, it says, given the probability for an event E, find the odds for and against. Okay, so basically on this is I'm giving you the probability of this is 3/8. So the probability against would just be 1 minus 3/8. You can do this in your head. So you would do 8/8 minus 3/8. So that would be a 5/8 probability like that. Okay, if you want to find the odds for, then what you would do is the odds for, what you would do is you would do this. Okay, that would be equal to the probability of the event happening over the probability of the event not happening. So the probability for is 3/8. The probability against is 5/8. Again, the 8's cross out, so what we would say on this is we would just have 3 to 5 odds. Okay, so that's how that would be put together. Now, the odds against would be 5 to 3. So once you know 1, you can automatically just flip it backwards and do that. But the way this one would work is the odds against would be the probability of E not happening over the probability of it happening. So now it would be 5/8 over 3/8. So it would be 5 to 3 odds. Okay, like that. Okay. All right, the next one is going to go like this. So we have the probability of an event's 0.4. Therefore, the probability of it not happening is 1 minus 0.4. So that would be 0.60. Again, these things add up to 100%. 40% and 60% is 100%. Okay, if we're going to do the odds for, then we would use the formula. So it would go like this. It would be the probability of E over the probability of E prime. Okay, so you can do this. The probability of E is 0.40. The probability of not happening is 0.60. Now, what you can do on this basically is you can move the decimals over the same amount. Now, you can't move the decimal over 1 on top and 5 on the bottom because you're changing the problem. But in your head, you can just imagine changing the decimal over 2 to get 40/60ths. Okay, and then you can reduce that fraction. You could cross out the zeros, so that's 4/6. And then you could reduce that fraction by 2. So you would end up getting 2/3. So as far as writing that as an odds, you would want to write that the odds for would be written just basically as 2:3. Okay, like that. So that's the odds for. Well, the odds against, well, you can just do that in your head. So the odds against would just be backwards of this. So instead of 2 to 3 odds, that would be 3 to 2 odds like that. Okay, so that's how you do that and get that put together. Okay. All right. Okay, now this one, you're given the odds. So these are 2 to 1 odds. And you're going to assume that it says odds in favor of. So that's in favor. So what we're going to do is we're going to determine the probability of the event happening on this then. Okay, so we use this formula. So the formula would go like this. The total would be the denominator. In favor is the 2, so it would be that. Okay, so that would be a 2/3 probability of the event happening. All right, so that's how that would go. And by the way, the probability of E not happening would be 1 out of 3. See, those two things are going to add up. Okay, the next one, same thing. This would be odds in favor. If you had 5 to 3 odds in favor, then the probability of that happening would be the first number 5 over the sum. So that would be 5/8. Okay. And then if you want to do the probability of that not happening, then it would be 3 over 5 plus 3. So that would be 3/8. So you want to notice on this is those probabilities are going to add up to 1. They always will. So if you're given odds 4, it's easy to find the probability of, and it's also easy to find the probability against. Okay, like that. All right. Okay, so let's see. Go down the bottom. I'm going to have you do these 2 problems. I obviously don't know how to count, so that should be number 2 and 3 like that. Okay, so use the spinner to figure out the odds, and then I want you to see if you can convert odds back to probability then, and then we'll wrap up the last page here. So you can pause, come back and check your answers. Okay, so you want to go ahead and check your answers and see kind of what I did. I'll go over these in just a second here, so I'm just going to read out what I got. So the odds against orange, you can write it as 4 over 1, 4 to 1, or 4:1. The odds for red or green, you could write it as 2 over 3, 2 to 3, or 2:3. And then on the second one, if your odds for were 5 to 1, that means the probability of is 5/6. This one, the probability of an event is 0.2. Then the odds for turns out to be 1 to 4. So let me explain kind of how I did. I'll kind of talk through these problems for you. Okay, so when you're doing the odd against orange, you're doing the probability of orange not happening. So it's O prime over the probability of getting an orange. Okay, the probability of not getting an orange would be 1, 2, 3, 4 colors out of 5. Probability of orange is 1 out of 5. 5's cross out, you got 4 to 1 odds. Okay, and notice if you put this back together. So like if you have 4 to 1 odds, that means 4 out of 4 plus 1, so it's back to 4/5. Okay, that's how you can check and make sure you're doing that right. Okay, the next one was the odds for red or green. So you're going to do the probability of red or green over the probability of not red over green. Okay, so red or green would be this or that. That would be 2 out of 5. Not red or green would be the orange, purple, or yellow coming up, so that would be 3/5. And again, notice on this odds, these 2 things right here are always going to add up to 1. 4/5, 1/5, 2/5, 3/5 adds up to 1. The 5s would cross out, therefore you have 2 to 3 odds. Okay, and then the last 2 problems, you're just kind of seeing that you can convert odds back and forth from a probability. So this said the odds for an event, of an event happening, is 5 to 1. So the probability of would be 5 over 5 plus 1, or 5/6. And the probability of this not happening would be 1 to 6. Okay, so if you did those 2 things together, the probability of and the probability of not both have to add up to 1. Okay, next problem, I gave you a probability. The probability of the event is 0.2. So if you're going to do the odds for, you got to do the probability against. So if the probability of the event's 0.2, the probability of the event not happening is 0.8. So what I do is the odds for is the probability of E over the probability of not E. So it's 0.2 over 0.8. Again, notice I moved the decimal to the right 2 to get 2/8. Reduce the fraction, you get 1/4. So it's 1 to 4 odds. Okay. All right. So pause if you need to look at that and study over that for a few minutes. So that's a basic thing that you want to know how to do. I'm going to move to this last page, and then we'll put this together. I'm going to pause for a second. Okay. All right. So to wrap this up, this is when insurance companies calculate insurance premiums, the profession that does that is called an actuary. Actuaries usually major in math. It's something that a math major could do. I'd be bored to death if I was an actuary, but they do make big money. They make more money than a teacher does. That's for sure. But I'd just be bored. So the idea is they take probabilities and they try to establish risk and try to figure out how to charge customers in such a way so that things can be covered. So it's risk management. So what this particular problem is saying is it's saying this is the miles driven per year. So the drivers that drive less than 10,000 miles a year would be, that's a 0.20% probability. Okay, the drivers that drive between 10,000 and 15,000, there's 30% of those. That's a 0.3 probability. And the drivers that drive more than 15,000, that would be 50% or 0.5. So notice that these totals all add up to 1. 20%, 30%, and 50% adds up to 1. And then if you read it this way, these are the drivers that are involved in an accident. So out of this group that travel less than 10,000 miles, only 5% have an accident. Okay, out of this group, that would be 10% have an accident. Out of this group, 15% have an accident. So that's logical. The more you drive, the more likely you are to have an accident. And there's other factors too, where you drive, what kind of driver you are. You don't smoke crack before you get in your car, whatever, okay? I mean, there's all kinds of factors. This is kind of oversimplified. Don't drink and drive. All right, so this would be that group, and then there's 30% of the drivers do have an accident, whereas 70% have no accident. So you just got to read the table right. So what the question is saying on part A, it says the driver drives, there's two parts of this, they drive less than 10,000 miles per year, or they have an accident. All right, and again, this is an or probability, so it's real important that you identify that as the union. So once you see this or probability, the thing that you got to do is you got to put this together using that formula. So what I'm going to do is I'm just going to write this in symbols like this. I'm going to use variables. So I'm going to say L is you drive less than 10,000 miles. I'm going to say A is you're going to have an accident. Okay, so I'm going to use that formula for a union. So we're going to do the probability that you drive less than 10,000, union, you have an accident. So the formula goes like this. You do the probability that you drive less than 10,000 plus the probability that you're going to have an accident, and then minus the probability of the overlap or the intersection like that. So let me show you how we put this together. So the first thing we want to do is look at our chart and figure out what is the probability of somebody driving less than 10,000. Well, that's that number right there. The people that drive 10,000 is this column right here, but that probability is going to be 20%. Okay, so that part right there is 0.2. Okay, the second part is the probability that you have an accident. The people that have an accident are going to go this way. And that grand total is going to be 30% of your drivers have an accident. Okay. All right, so it's going to go like this then. All right, so I write down that probability as 0.3. Okay, so the next thing is they drive less than 10,000 and they have an accident. What's that? Right, that's this part right here. That part right there is your intersection. Okay, so that means that that probability, see, if we don't subtract that off, we're counting that twice. Okay, so what we need to do is we need to subtract off that 0.05. Now you can go to your calculator. That would be 50% minus 5%. That would be 0.45, or there's a 45% chance that somebody drives less than 10,000 miles or has an accident. Okay, that's how that goes. All right, the next one I think is an AND probability. So let me show you how this goes then. All right, so this one says, again, I'm going to write down the sets again. This one's, I'm going to say M for more than 10,000 miles. There'll be that set. And then the second set, I'm going to say N for no accidents. So it's a good idea when you do this to kind of to identify the sets and just use symbolism. Now, this is an AND probability, so we're looking for the probability of the intersection of these two events happening. So we got to look at this diagram the correct way, like this. So what I'm going to do is I'm going to just do M. I'm going to highlight the probability that you're a driver and you drive 10,000 or more. Well, that would be these people here, and it would be those people there. Don't look at the totals necessarily, because we're going to look at the intersection. Okay. The second one is going to be you have no accident. So no accident would be this one, and this one. Okay, what's the intersection? Well, where are the green, where did the numbers blend? They blended here and they blended here. So all we should have to do is just do 0.2 plus 0.35. So you would have a 0.55 or 55% chance of a person having no accident and driving 10,000 or more miles. Okay, so that's the difference between the and the or probability, like that. You do a union if it's or, you focus totally on the intersection if it's an and probability. All right, well, that should wrap us up and take care of everything we're going to do in this section, and hopefully you'll do well with this. All right, good luck.